Okay, our next speaker is remote. Ariana, can you hear us?
Yeah, can you hear me okay?
Oh, fantastic. And I think you're sharing and we can hear and see you. So, uh, whenever you're ready, our next speaker is from University of Wisconsin. And, we can't have any talk. We have to have at least one talk from Wisconsin that's about cows or dairy because they keep us all fed. So without further ado, let's hear it from Ariana.
Hi. Yeah, thank you for the introduction. I'm very sad that I cannot be there in person and present in person today. Unfortunately, I'm at a different conference. So if anything happens with the hotel Wi-Fi, please let me know. But I'm hoping that this goes smoothly. So I will be talking about utilizing the CHTC resources, especially DAGMAN workflows for my current research, which is high throughput phenotyping in dairy cattle. Um, and then just a little bit about my background. I'm originally from South Florida. So that's a picture of one of my favorite beaches that was a mile away from the high school I went to. So I don't have a background in animal science. I had never seen a cow before. And I didn't have a background in computer science either. But I went to Michigan State for my undergraduate and my master's, where I was introduced to dairy cattle. And my background was in nutrition. And it wasn't until coming to UW-Madison for my PhD that I started working in computer science. So this is something that a little bit of a perspective as I go forward in my presentation, that I'm not a computer scientist. I am an animal scientist. I don't know if I can ever truly call myself a computer scientist, but I'm becoming more equipped with it. And I am part of the Digital Livestock Lab at UW-Madison and the Animal and Dairy Science program. And we look at applications of machine learning and computer vision for farm management. And so there are a lot of applications for precision livestock farming. It's becoming more and more adapted on commercial farms. Anything from animal level information like sensors, pedometers, we call them like Fitbits for cows. Those are becoming very common on commercial farms. There's also different things on the crops and soil sciences side. And so there's a lot of information that we can get from these animals. And my research is specific to computer vision systems. And so I am towards the end of my PhD. I'll be defending in August. And over the last 4.5 years, I have been working on an edge computing system that collects depth and infrared images from growing dairy heifers. And so this is a picture of the UW-Madison facility at Marshfield, which is about 2.5 hours north of UW-Madison. And you can see here there's electrical boxes on each of those main posts on either side of the feed alley there. And those are all contain a Jetson Nano that's set up to trigger and take infrared and depth images of the cattle when they're underneath cameras that are hooked up to them. And here's just kind of a close-up of what that looks like. And we are following these animals from when they're born until the end of their first lactation. That takes about 3 years. So if you can imagine, if we're taking images from 34 pens every single day, it amounts to a lot of imaging. But here's kind of like a breakdown of our timeline. When they were really young, it's called the pre-weaning period. It's when they're still being fed milk. They are we collected images manually, and so on the left side of the presentation, you can see a representation of what those images look like. And then when they were moved to Marshfield, during their growth period, which is about a year and a half, 2 years, you can see the images represented there that we're taking, the infrared and depth. And then they got moved once they started lactating. They were moved to our facility, Arlington, which is about 30 minutes north of UW-Madison. And we also had the same system collecting images, and you can see here. And this amounted to about 200 terabytes of data and over 15 million images. And that's where we needed help from CHTC because we have a lot of processing that we're trying to do. The main goal of this project is to look at growth factors and predicting lactation and using different deep learning machine learning models in order to predict which animals are growing well, if there's any nutritional or environmental interventions that need to happen during growth, and also seeing, okay, which animals do you want to sell or keep into your herd based off of their growth and predicting their future lactation. But in order to do that, there are a lot of steps. So first, we have these tar balls that we saved from those Jetsons as they collected images, and we need to extract the frames from those. And then we perform semantic segmentation on the animal body and then classified if these were good or bad segmentations. These use pre-trained deep learning models. Then we have some image pre-processing that we do. We perform individual identification using a triplet-loss Siamese neural network. So it's another deep learning model. And then we can finally perform that feature extraction from the Dept images, and that ends up with tabular data. And in order to process all of this data, I cannot express how grateful I am to the CHTC and to all the people there that have helped us, because otherwise I would not be able to do any of my research or process this data on a local machine. So we use HTCondor, Pelican to transfer the data, and also DAGMAN workflows. And I'm not sure if there's already been a lot of presentations on DAGMAN, but this was taken from a YouTube video that I watched multiple times trying to understand how this works. But it's a directed acyclical graph where you look at job submissions and parent and child nodes as part of those submission pipeline. And so each one of those steps that I talked about is a node in my DAGMAN pipeline. So we have the A jobs and well, first the data is transferred via Pelican from our external storage servers. So we have some servers that we were storing all of our data on hard drives, and then we were able to work with the CHTC staff to set up a transfer system between those servers and the CHTC resources. And then we have multiple different A nodes depending on where the images were saved and what form of images. So we have videos and images in different formats there. Then we have two different segmentation models. We have one of the good bad for filtering out the bad images. We have two different nodes for pre-processing depending on setting. We have four different trained Siamese neural networks depending on, again, the stage of life that they're in, and then a final feature extraction phase. And it's just kind of a screenshot of what our batch organization looks like. So for submitting the jobs, I put in the original source. So this is part of what Pelican uses to transfer the images. Then I have where I want the output to be of the child nodes and the specification of which parent and child goes afterwards. And in order to optimize this, I have a Python script that reads this batch information and generates the DAG file and cleanup script for each of these parent and child dependencies. And then I was just going to show a little bit of results in case anyone was curious about, okay, we have all this information, all this data. So from the features that we extract at the end of this pipeline, we're able to look at these biometrics from the depth images, things like circularity, area, volume, height, widths, and we can classify growth curves. So you can see two different calves, they have the same weight over time, but they have different heights as they go, and this can mean different things for their hormonal status or reproductive, as well as looking at different phenotypes that can be used to predict lactation potential and also general health and welfare of the animals. And just some exciting results. I'm very excited. Again, this was a very long project and it was a long time and a lot of work without any kind of results, setting up the pipeline and collecting and processing the data. But we can see over age, we have up until 200 days. So this pipeline is currently running at CHTC. I apologize for using resources because we have about 900 jobs running at once at any given time. And I've been working with the CHTC staff to make sure other people get a fair share at the CPUs and GPUs as well. But definitely using some resources currently at CHTC and having a lot of jobs running. But it was very exciting to see now we have up until about 200 days and we can see the weight, which is like the ground truth that we collected, and also the volume, and they're highly correlated. So basically saying that you don't need to weigh these animals manually, which can cause stress to the animals, injury to the animals, and also to the workers. And it's very labor intensive, which labor shortages are issues on farms right now. So you can just have a camera up and it can automatically record what the predicted weight would be of these animals. And so this pipeline, what we have processed so far, again, I'm saying that it's still running. We only have about 25% of our data processed, but it's had about 44,000, over 44,000 DAGMAN jobs, and about 25,000 wall clock hours. And so if you multiply that by 4, that's probably what I'm estimating what we will have used to process all of this data. And I was asked, for some key takeaways, and honestly, I'm sure everyone here that utilizes any CHTC resources can agree with me that the staff is incredibly helpful. They've helped me troubleshoot so much. Again, with my background not being in computer sciences, I have had to learn a lot, but they have always been there to answer any question that I may have, and especially Dr. Andrew Owen has been incredibly it has been a really, really great resource and always very kind and helpful to any problem that I might be having. And these resources have allowed me to support my research. And again, this is something I would not have been able to do with any of our departmental or lab servers that we have going on. I would say the only limitation or thing that I have struggled with as part of this project and working with CHTC is the data transfer, which again, everyone has been really helpful in finding solutions and helping work with me on it. But the data storage is just a personal struggle with us having to figure things out as we go. But again, it's now running really well, and it's something that, again, I am nothing but grateful for all the help that I've gotten. And so, with that, I want to thank my lab group and all our funding sources and collaborators and the staff at CHTC for help with this project.
Thank you. Do we have any questions? I see a bunch of hands coming up.
Hello. So I actually had the distinction of being sent to the farm at one point to help do some data collection. This is many years ago. My understanding is that they have collars that let you identify them, but it sounds like you're not using that information.
Yes, so there are, again, those are under the broad scope of wearable sensors. So there are collars and also RFID tags that animals can have that can help you identify them. However, there is still, I would say there is a reliability issue with them still, especially the RFID readers, like on the one system I didn't explain, but the cameras are there, and we also have an RFID reader to read the RFID information for each one of those, and it wasn't reliable enough to use, and that's why I used the Siamese neural network with triplet loss, because they can read like there's noise from other readers, or they cannot necessarily like sync up with the camera well enough. And that the individual identification is a really hot topic right now in animal agriculture in general, is using computer vision for individual identification because of the limitations posed by those wearable sensors.
Gotcha. So how confident are you in your identification using just images?
Yeah, so that was a paper that I'm getting ready to publish right now that I'm excited about. So It's never been done in growth phases for dairy cattle. It's been used on like only mature dairy cattle before, and we were able to get a accuracy of 0.93 for our model that we trained.
And next question.
Yeah, so I maybe have a follow-up to that. I was kind of curious of what your perspective is in terms of like real-time applications that you would see as the most, um, you know, interesting moving forward, because obviously this was like a long-term study trying to prove the models and things like that. But, you have like the Jets and Nanos there. Like, I'm kind of curious what your perspective is in terms of the computer vision, like real-time applications that you see.
Yeah, yeah, absolutely. So that is the long-term goal, right? Is to be able to have a system that can be applied on farm and industry. And the just the nanos that we have were underutilized. So I said edge computing at the beginning, but it wasn't true edge computing because all we were doing was having it trigger based off of the average depth and seeing if there's a cow in the frame and then saving the images and writing it. And so we did purchase those Jets and Nanos because the end goal is to have this pipeline be able to be deployed locally and just save the tabular results at the end because that uh, reduces the data transfer, the internet connectivity issue on farms, and also the data storage issue that I personally ran into a lot on in this research project, saving all the original infrared and depth frames.
All right, this is Christina from CHTC. First, Ariana, you never need to apologize for using lots of cycles. The goal is to be greedy and get as much as possible, so carry on. But second, this is more of like a general question. So you mentioned, your background isn't in computer science. This is a huge project. Are there any, like, I don't know, general tips or things you learned? Like, how did you approach this? From like you came in and someone was like, okay, you're going to do this big project analyzing all this data, like things you learned that were useful. Like, what advice would you give to, yourself 2 or 3 years ago?
Oh man. Hi, Christina. That's a question, right? And I don't know if I have any advice. And I think like towards the end of anyone's PhD, you're kind of like, do I know anything? But looking back at when I started, I definitely learned a lot. I mean, I again had never used Python before. I like my first semester, I took Intro to Python and like an 800 level computer vision class at the same time. And many tears were shed. And so there's a lot of things I think in retrospect, looking back on a project like this that I wish I had known ahead of time. Even just things like the way that I'm storing data, the way that I'm organizing it to make it easier to go through this pipeline at the end. But I mean, we have some people on our team that are from a computer science background, like, Rafael Ferreira. He is a computer scientist by trade. And he was even like, oh, I wish that we had known these things. And it's just a very unique and different application that comes with its own unique issues. So I would say my main thing was, asking for help, which I did do a lot of, but I think there's sometimes where I was struggling and I was wanting to figure things out, but I ended up wasting a few weeks of my time just trying to troubleshoot an issue that if I had asked one of my lab mates or someone from CHTC for help, it would have been resolved quicker. Another thing working with CHTC in general is like, I think I even now tend to doubt myself a lot, where I'm like, oh, this is a problem with my code. When in reality, it could be that, something is happening on the CHTC side that I don't know about. And so that's another thing where I will spend a lot of time like trying to figure things out on my own instead of reaching out for help, which again, Andrew has been very, very helpful and kind to me where I feel open asking him like, hey, I'm having this issue. Can you let me know if it's something on my side or not? So.
Thank you. If there's no more questions, I'd like to briefly abuse my moderator privileges and warn you that if you use the term tarball in casual conversation, you may be a computer scientist. So let's give a big round of applause for our speaker.